Alright, so let's go. Just have to continue. Okay, so this I'm going to present joint work between Brazil and France, and it's mostly the work of the two Gabriels and Izabela. The two guys at the end are the bosses that didn't do anything except travel here. So how do we address the task? The idea is pretty simple. We address the task as a graph approach, where each node in the graph, where you see the guys are the nodes in the graph, is a speaking face. So it's a segment of video where someone is speaking. And obviously between speaking faces we can establish similarity, face similarity using some face features, or voice similarity using voice comparison techniques. And some of the nodes we can also tag, because we know that the name is written big on the screen while the guy is talking, so we are pretty sure that this blue guy here is John because it was written on the screen. So some of the nodes we can tag, some of the others we can't tag, but we have this face and audio or voice similarities. So the idea is that we're going to propagate the tags from the nodes that we know to the nodes that we don't know, and then we can label in this way all the speaking faces. So just an idea of the proportion that we get in this year. With the initial labeling stage, we have 6% of the nodes that are labeled, and we're going to propagate the names on those labeled nodes to the remaining 94% nodes. So how do we construct the graph? So a speaking face is just someone speaking. We have face tracks, and we see if a face track overlaps with speech in the audio track, and if there's a face on the screen that overlaps significantly with speech in a thing, it's a speaking face. And if there's a name written on the screen for a sufficient amount of time, then we can name that thing. Second point is, how do we establish the visual and audio similarity? So visual similarity, we take one image of the face track, we extract a bunch of CNN features, and then we can establish the distance between the CNN features. These CNNs were trained for object detection, they're not specific to faces. And then we have this cosine similarity. The voice similarity, we try two different things, either a binary, 1 or 0, it's the same voice, it's not the same voice, and this binary thing is based on diarization results, where people grouped segments from the same speaker. And we also tried, as Gerald put it during lunch, old-fashioned approach, where we use Gaussian mixture models of the voice and distance between the Gaussian mixture model, and then we make a fusion of these things. Propagation. So now we have this graph that is, some of the nodes are tagged. We have the voice similarities, the face similarities. Well, we combine those similarities. So we're going to propagate the tags to the unlabeled nodes in the graph. Well, I don't want to go into much details here because I didn't do the work, so I'm not sure I'm aware of all the details. So the idea is so these are the labeled nodes, and we're not going to question the nodes that are already labeled, but the question that we ask ourselves is, how likely is it that we find a path from an unlabeled node to a labeled node? And we can compute this for all unlabeled nodes, how likely it is that it corresponds to this one or to the orange one, and just pick the best one. So that's basically a matrix operation on graphs to find the probability that we go from one non-labeled node to a labeled node in a number of steps, and then we can label an unlabeled node like this. Second strategy that we used is based on a minimum spanning tree. I'm not really familiar with this, so this is the Brazilian work. I think the way I understand it, the idea is that we're going to break the whole graph into trees, and this minimum spanning tree, and the nodes in a tree are very similar one to another. So basically the nodes in one minimum spanning tree are close connected components in the initial graph. And if within those connected components within the graph we have a tag, or several times the same tag, then we can pretend that all the nodes that are in this minimum spanning tree are tagged. So it's a bit more subtle than this, but this is globally the idea behind this thing. And again, this works as a tag propagation strategy. So once we've done that, either random walk or minimum spanning tree tag propagations, all nodes receive a tag, however, with a different probability. So we filter out the tags that have very low probability, that's very unlikely to be associated with a given node, and we just have the remaining ones that we use to provide a solution. Result-wise, in 2 minutes, so we have a baseline that is C4 without any tag propagation. We have a number of contrasts where we vary the tag propagation algorithm, random walk versus minimum spanning tree or hierarchical, and we vary the combinations of audio similarity and voice similarity and face similarity. I'm going to walk you through quickly the results. So this is the baseline. This is development data that we use. This is the test from last year's data, the test from this year's data. But let's focus on the map mean average precision at 10 and this on this year's data. So that's the baseline. If we don't do any tag propagation, we have 36% correct. Any of the tag propagation techniques improved the results, which we were very happy with. If we look at the different contrasts, we can see that a random walk works slightly worse than a minimum spanning tree, though it's not very significant. And the best run, the primary, we made a good choice in choosing this one as primary run, combines, so it's the minimum spanning tree propagation with binary audio features and CNN visual features. Just quickly, the fact that binary audio features works better than the GMM-based comparison of voice is due to the fact that this binary audio similarity comes from the speaker diarization, which is initially pretty good, so we can't really beat that with an old-fashioned system. So to conclude, well, we're quite happy with the results because tag propagation worked pretty well this year, while last year it didn't work so well, so we were happy to see this. And obviously this is because it was more crucial in 2016 to do tag propagation than it was in 2015. Next steps, well, do better, obviously. So there are a number of ways we can obviously improve voice comparison, and we're working into this. And improve the initial labeling, that's the crucial step. We assume that the labels that we put initially are all correct, and we're never going to question them. So if we make an error there, we're going to propagate the errors until the end. So we have to work on this step, and obviously we did things at the last minute in a rush, and we didn't really tune things, fine-tune, and that's what we're going to do now. Thank you. Thank you.